and he's going to talk about performance and energy efficiency optimization of Docker.
Okay, good morning to everybody. Just to introduce why I'm doing this speech, it's basically something that I'm doing in the research, and it's of course something important nowadays, not only the performance, but also the power consumption of the software that we do. How many of you code? I mean, are developers or doing some code? Okay, so most of us normally, I imagine, we feel like very happy when everything is working, and we almost think that, okay, that's done. But it's not really always true, because sometimes we find some problems in the testing part. And until now, it was a choice like, okay, we want also test the performance, and nowadays is also we want to make our software more power aware or not. This is the goal that we have, and just to introduce the part that we use a lot, it's the Docker container, and this part it's what we observe. Just to are not familiar with Docker, but I suppose most of us are. We put some code inside the Docker container, and this Docker container includes everything that we need to run correctly our application, so framework or databases or what we need. But we have not really a specific idea about what's happening from the energy point of view. So, in which part we can measure this kind of data? It's inside a DevOps. So, in the DevOps pipeline, we can measure this part in the testing part, because basically we need our software that is running, and also to generate some load on it. To do this kind of stuff, we use different tools. So basically Docker to put the code, Locust that we will see in a moment make a load to this software that we want to test, and then Scaphander that which collect the data about the power consumption of different processes in the system, and the C-Advisor that give us a lot of data about what's happening inside the operating system, like CPU usage or memory usage, different stuff. So Locust, it's a tool that make a stress test on API. So on the low part here, we can see the response time. That is a metrics, an important metrics for this kind of system. And Locust generate, for example, multiple user requests made by API request, and can also generate some specific workload, like first login and then ask some data, and after that made a post with edit something and so on. So this is a schema how we collect the data and how we process this kind of test. We have two mainly parts, two devices. One is the driver, which have to execute the test, execute the Locust, and generate this load. And the test bed on the bottom part, which have the duty to just run the software that we want to test and collect all the data, all the metrics. And of course, if we want, we can also provide like a physical device to collect some data, but it's an extra. It's enough to have the data from the Scaphander, and Scaphander gives us many data about what's happening from the energy point of view. So just to explain a bit how does it work in the automatic way inside the pipeline, Once we make a commit, we have the GitLab runner that is running inside the driver. And this part starts to execute everything we want in this case. Especially, I use the pptam tool that execute multiple kind of action, but we can use everything we want, or we can create a small tool that do this part. And after that, we have the deployment part. So the test, basically the software that we wrote and passed the classic test can go in this phase and be deployed in a Docker container directly in the test bed. Once it is in the test bed, the test can start. So basically, pptam start the testing with Locust, and we collect the data at the same time from Scaphandr, CAdvisor, and the Resource Agent, which are running into the test bed. Okay, now just to explain one part that it was not so easy to manage. I mean, we normally get the data about what's happening process by process in the system. So every PID have a power consumption. For example, here we can see an example of the data that we have. And we also have some data about CAdvisor that give us exactly what's happening in the system. And this is important also to know if we are stressing, for example, the system or if the load is too low. Because if we have like 1% of usage of the CPU, basically the data is not so relevant about the power consumption. So the main problem with the containers, it was that each container can use multiple PIDs, and we have no idea when this happened, because it depends about what is inside the container and what the software doing. So in the end, we collect the data from different sources, and we have, for example, here the list of the PIDs that the Docker container using, and for each PID we have here there is the PID number, and for each PID what is the power consumption in that time. So in the end we have the mix of those data, and we can know what is the power consumption of a specific Docker container. So this is an example about what is the output of this system, of this test. And we have, for example, here, we execute a typical performance problem that is a hiccup. Basically, the response time of the system have a normal level, but in some moments, in a repetitive way, this performance degrade, have a degradation, and then come back in a normal situation. So we can see something, okay, 95% is basically how much time, in how much time responds the API. And we can see the power consumption, this is this line that changed. And we calculated also the part that, also the metric that is basically this line and this line. And this black line explain or show us how much power consumption we use to answer to one request of the API. And this initial part is just because basically the system is just started, and the first request require a lot of effort for the software in that moment. So just to recap what we have something that we can test for each commit, each release that we have in the software, can make automatically a performance test and also power consumption test, which is something that nowadays I think is becoming more interesting. So thank you very much, And of course, I am here to answer to any question and also after it.
Thank you very much, Alessandro. We can take a lot of audience questions, so please raise your hand if you have one. We've got one in the back.
So you mentioned you use Docker Swarm. Have you tried something like this on Kubernetes?
No, actually, I didn't try with the Kubernetes. The only part similar, it's we use the Swarm, not Kubernetes. So there is some part is that managing. With the Kubernetes, for sure, it will be more complicated. It's clear, because the data that we collect are, of course, on a single machine right now.
Thanks.
Okay, we've got a question in the front.
How does Skephendry actually get the data? Is there an interface to the hardware already? The power consumption.
Sorry,
data.
which data?
The power consumption data.
The power consumption data come from Scaphander. That is a tool that collects the data, the information from basically the operating system, and is directly the CPU that is have one component that is a RAPL, and this part show some data about the power consumption of the pits.
Okay, do you have more questions? Then I have a question as well. So have you tried, or what have been your experiences? Have you found some things that someone maybe would not think about that have a significant impact on energy efficiency? Like what kinds of things that maybe people don't think about, would you say have an impact?
To be honest, for the moment, we didn't use in a lot of context this kind of process, because it's almost, I mean, we just finished 2 months ago to complete this pipeline, everything that is working completely. So we're starting to execute this kind of test on multiple type of software and classical software problem of the performance. So we will see soon.